So because the cranks are at 180 degrees, so phi 1 is 0, then phi 2 and phi 3 are 180 degrees, and phi 4 will be 0. So you can see 1 and 4 at the same position. So the section view you can see here. Now from the section view, can you tell me what is
Okay.
Khalid, right? Moment Khalid? No? So anybody forgot to clap the attendance? No? So we have 3 students. Edmund is here? No. Andrew? Ray Andrew? No. All right. So you may note down the information. Can you tell me what is A1 in this case?
0,
All right. A2?
4,
A3?
4.
A3 is the distance from 1 to 3.
Oh, A, 8,
Okay? Then A4 will be
12.
5. So just be careful about that information. Then, so I'll take this out. You know, I'll be uploading this file, so you will have the information. So you can write A1 is 0, A2 is 8, A3 is 5, sorry, A2 will be 4, A3 is 8, A4 will be 5. So find out what is sum of cosine 5. Sum of sine 5, sum of cosine 2 5, sum of sine 2 5. So any answers for the first one? Okay. 0, 0, 4, 0. So how can you write some of the primary forces? Some of the 0. Then some of the secondary forces. Cos 2 theta squared is 4.
응? 수? 수? 야, 이거 뭐야? 야.
Okay. So you can write 4 mr square omega square cos theta 1. Okay, so checking force S will be so sigma Fp plus sigma Fs. So Fp is 0. So we can write 4 Alright. So next we need to check the moments. Alright, so next we need to do the moments calculation. So for moments, so we need to do sum of A cos phi, sum of A sin phi, so sum of A cosine 2 phi, and sum of A sin 2 phi. So just calculate and let you know how much. So, so this means A1 cos phi 1 plus A2 cos phi 2 plus A3 cos phi 3 plus A4 cos phi 4. So, etc. So So you can write the remaining terms accordingly. So please give me the values for sum A cos phi. 0. Sum A sin phi. Also 0. A cosine 2 phi. How much?
24.
It should be 24. So we will get 24. Sum of A sin 2 phi.
0.
0. So then you can write what is CP. So CP will be
0.
0. So CS you can write it as 24 gamma square omega square
Cos
over L cosine 2 theta 1. So then the line of action for the shaking force so AR we can write it as C over S. So movement, total movement over shaking force, total force. So can you find out how much is this? So 24 mR square omega square cosine 2 theta 1 over 4 So what you get? Yeah, the answer is just 6.
So, you send me the email again.
I will try now. What's your name?
H3834812.
Yes?
H383
3, 3,
4812.
4, 8, 1, 2.
Yeah. Students.rmit.edu.au.
I repeat, yes, 383481. So did you receive the Word document? There is no document. I have in my side folder. Otherwise, this thing is just taking snapshot and so you emailed all right, guys, so you're done this, right? So next we'll move on to so the last part of your assignment is on shaking force and shaking movements. Okay? So this is the last part of the assignment. Anyhow, I will be uploading this file, so you will have all the information. So for the last part, you need to do the calculations for the shaking force. All the required equations are given to you. Okay? So this is where you are calculating the shaking force due to all the ground forces. Okay, the sum of the ground forces. So you need to calculate 2-1x, 2-1y, 4-1x, 4-1y. Okay, then okay. So calculate the resultant force along x-axis, the resultant force along the y-axis. Then you will get the resultant force. Okay. So square of this plus square of this, so you also know the orientation of the resultant force. Okay, so these are some calculations. Okay, then you need to calculate the torque acting on the system. So this is from your force analysis. So once you do your force analysis, so you also know your torque, external torque 2-1 or 1-2. Okay, so you will have the external torque. So then the shaking movements will be the sum of these three. So this is again a vector equation, so you need to write down the scalar formulation and just calculate what is the shaking movement, sum of the shaking movements. So everybody will have a different set of values, but essentially your equations will be the same. Okay, so once you write your scalar equation, it will be like this. Okay, so tomorrow I'll be uploading this document, so you will have this. Then you need to provide this working model simulation. Okay, so this is where this 6-bar mechanism is set up. So all the meters shows empty. Okay, so once you put your 60 degrees or once you complete your rotation and stop at 60 degrees, so you can trace the movement of the point C, I think. This one, this is point C, this is point B. Okay, this is point D. This. And you print all the meters for the velocities, acceleration, and the forces. So whatever the values comes, you need to just provide in the final consolidated table. So in the consolidated table, you are going to give the velocities by your polygon method, your IC's method, your analytical method, and simulation method. So velocities, you have 4 set of values. So similarly, accelerations, you have polygon method, then you have analytical method, then you have the simulation method. So then you will have force only by the calculations and working model simulations. Okay, so all the values in a neatly consolidated table. So the consolidated table is available for your reference on the learning resources. So for the assignment, how you simulate the model. So there is a document, right? PDF document. So at the end of the document, you can see how you can organize the final set of values. So the good thing about the first assignment, so we have nearly 1/3 of the class got full marks. So I'll tell you the positive side. So you can still try to get for the second assignment also like that. So in such a case, that means you got good grasp of the topic, then you can surely get high distinctions.
So for the tabulated result at the end, right? Some of them they double match for assignment 1. Do we use the same values or
You have to use the same value. No, let me tell you, if it doesn't match, so out of 20 you may lose 1 or 2 marks. So what is important is the way you document your report, okay? So the way you show the details of your working. So the final values, I don't care. So in the worst scenario, you may just lose 1 or 2 marks.
So you don't care, then no minus mark.
I don't care, but I care for 2 marks. I make you 1 mark. So it's not that giving a 0 or something. Okay? So it is always like, even in your exams, even your final answer doesn't get, okay, you still get 60-70%. You will not be given 100, right?
So we just use maximum value.
Say again?
As in we don't need to try and correct the previous assignment values.
No, you can't. Yeah, so you should never do that. No, because I have set of values, so I know whether you're. So in the first scenario, I told you, people got 80%, 90%, nearly 1/3 of the class. So 1/3 is full marks, so the answers are near perfect. Okay, though there are minor things, but still, and 1/3 of the class got anywhere between 70 to 80%. But again, 1/3 of the class I can't say. So that 1/3 of the class should be really must do well the assignment too, and if not, the exam you must do well. So exam, as I said, I'll stop. So part 8 of the assignment is only writing about the shaking force. So all the required equations are there. So for assignment 2, for example, if you do working model, demonstrate that you are done for your setup. Okay, something like that. If you show, it doesn't matter even if your values coincide or not. But let me tell you, for those 1/3 of the class, definitely they will coincide, because the simulation is the easy part. So this particular mechanism, designing, it will take half an hour. And running, probably struggle 1 or 2 times. So you just take the screenshot and show. So I know that at least you've done the simulation part. So if there is some, let us say 10% weightage for this, you do it correctly, you'll get 10%. Let us say you're done, but there are some mistakes, you may get 7 or 8. Definitely not 10. but definitely 7. So 7 or 8 means already distinction or high distinction. But there must be effort and there must be screenshots, and the screenshot should be from your side, and you can't take the screenshots from other people. So if you know, I will be going. So I have not penalized you, but definitely you will not get 70% or 80%. So you may get 30% or 20%. No, because it's a small class, it is a 250 students, it's very difficult to pinpoint, but 30, 40 students, we know easily. Okay, and always, please take note that, we want to encourage you, it's not discouraging you, so we always want to bring the best out of you. And this is a long-term process, once you go into the real life, your attitude matters, right? And the way you, work in the work environment, a team player. So ultimately the material success or the real success comes to based on your attitudes, not entirely based on the knowledge. Knowledge can be helpful, but attitude is much more important. Alright, so be a team player and take positivity. And you learn things, once you learn things, it reflects in your face. So if you go to an interview or if you go to a meeting, then you will be able to talk confidently. Alright, so we stop about the assignment. So any questions about the assignment?
Yeah, sorry. I follow the slides for theta 3 and theta 4. I cannot get anywhere near. I compare both method, the slides that you give and also the learning guide one. There
are some typo errors, I think. Paper pointed out those things.
Yeah, I tried to correct the typo also, but then I cannot get anywhere near the because these figures is given to us, so it's a bit.
What I can do is I can probably just email to me. I'll provide you detailed calculations, how the calculations are done.
Okay.
So because I have given you only the equations, right? So
yeah.
No detailed calculations.
Okay.
So I'll be able to give you a model detailed calculations, then you can pinpoint where your calculation errors are there.
Okay, I see.
Okay, so if you have any difficulty, you can always email and there will be some help provided. So I think some of you always do that, but not all. So if you have difficulty in calculations, as we said, okay, so I can give you a bit detailed calculations, where at least you come to know where you went from. Alright, anything else about the assignment?
That's all.
Normally every term, I think every year, 1/3 of the class gets full marks for assignments. So I'm mostly worried about the remaining 1/3 who gets less than 50. So, yeah, so those guys you need to do well in the exams. Okay, so now coming to the end of term exam. Okay, so please note, okay, I write the first point. Okay, so don't miss the pre-exam workshop. No, every term, the people who gets low marks, they are missing the pre-exam workshop. If he thinks that his friend is attending, so he can get from them, it is not possible. Because he is coming all the way from Australia, he's spending 3 days of his time here, and you can't afford to miss. So don't miss the pre-exam workshop. All the sessions, every minute. So because normally he will go through only 5-6 questions, and very similar questions will come up. And each question he may be spending more than an hour. I don't have the luxury to spend 1 hour for one question. But since it is a pre-exam workshop, they will do only few questions, but in details. No need for any cheat sheet. Only for the balancing equations. For that also, only for the inline engine balancing. So only FP and FS, CS and CP. Otherwise, all other things, you can use graphical method. Alright, so there will be 4 questions. And of course 3 hours. Anyhow, the school will send you a detail about this. So this is from my side. So you will have 15 minutes reading time also. Okay, 4 questions. Generally, the first question, 30 marks. Okay, and this question deals with velocity and acceleration polygons. Okay, so second question, 30 marks. Okay, IC's method. So this is where actually some of the students, they don't get any marks. Mainly because they can't even identify the pin joints as the ICs on the figure. So probably, they go blank or something, so it happens to less than 5%, so it's not a big thing. Okay, IC's method, identifying all ICs. And calculation of velocities. Of only 1 or 2 points, so you are not calculating velocities for many points. So as a rule, it will be a 6-bar linkage mechanism. So don't expect any 4-bar linkage mechanism. So all the students who are just using the cell phones, I am taking all the trouble to write. So it will. No, I am not talking about those who are writing. The beauty of our human mind is that, within 15 minutes after leaving the class, you'll forget everything. What all we have done in the 3 hours. But how to improve the memory? So one of the best thing is write yourself. Okay, your handwriting is the dearest thing. Let me tell you, there are some jokes about what happened during the COVID 2 years. So some of the students forgot to write. So particularly, some levels of students, they forgot to write in the exams. Yeah. The writing is so bad, they could not express themselves. But the same thing, they can do it on computer better. So now we have to go back to the basics. Use pen and paper. Okay, the third question is about force analysis. Yeah, 20 marks. Because 60 marks are gone already. So the remaining 2 questions, 20. So this is where draw free body diagram for the links. This is the 4-bar linkage mechanism. derive expression for forces using a matrix form. So the final expression should be in the matrix form. So we have done few examples, and also these things are available on the learning guide. Okay. So in the codebook exams, actually most of the students used to get full marks for this. So that means in the online exams, COVID exams, because they know they can always refer the material and write down. Okay, so the fourth question is again for 20 marks. So this is from balancing. Okay, so here you may get a simple dynamic balancing. So the question are inline engine balancing. So easy to score Q3 and Q4. So this one everybody must get. If your assignment marks are low, so you must get full marks per year. Okay, so and I strongly advise you start working on these two first. No. So you can complete both the questions if you know in 45 minutes to 1 hour, and you will have a lot of time to focus on question 1 and 2. Question 1 and 2 because of graphical methods, so you may take long time because if you don't practice on paper, at least for some questions, you know, or it will take long time, and sometimes you may get confused in the exam. It's 3 hours tension. And if you start with question 1 and say you are not able to go to question 2, again, a lot of time wasted. You may have little time to do question 3 and question 4. So which are easy to score. Okay. Strongly recommended start with so Q3 and Q4. Though the questions have less marks, but it is likely that you can score well. But if you are confident about the procedures of your velocity analysis by polygons or the IC's method, you can do it both the questions in less than 1 hour. But it requires some amount of practice. So the clue, follow carefully Professor Firoz session. Okay, so he will spend more than an hour for one question on ICs. So your ideas will be reinforced. So you will be much clearer. So if you are not very clear now, once you attend the exam, you are okay.
So the exam give up or not give up?
Actually, it's a moderated marking will be done by me, so they will moderate it. All right. So, any other questions? So, I have touched upon all the assignment parts. Okay. So now the second part is starting first analytical calculation. So all the equations are there. So I don't mind if you just cut and paste and use the equations, no need to type, but the calculations must be there, the numerical values must be there. Okay? So in the worst scenario, if you can't type and it's taking a long time, you can neatly, you can do handwriting also, the analytical part. Okay? So after the analytical part, then you have the force analysis. Okay? So all the equations are there, then working model simulation and the shaping force, shaping moments. Okay, so the force analysis is again a challenging part because I gave you the entire matrix. So you are going to just put your values, whatever the values you calculate, then use any software which can solve matrices. Okay, so you can use online calculators, you can use your MATLAB, or you can use even engineering equation solver you can do. Okay, so but it requires so some mathematical software. All right, so I just go back. So you can see here the first part is the graphical velocity analysis. So always okay, so we start with the relative velocity equation, right? So velocity of B is velocity A plus velocity B2. Okay, so velocity A, you always know the information. So we always know the information. So this is the 4-bar linkage mechanism. Okay, so you have a ground link, link 2, this is the crank. So link 3 connecting rod, and link 4 is connecting to the again ground. Okay, so velocity A will be perpendicular to the link. No angular velocity of the link. So therefore you know the velocity. So if the angular velocity is clockwise like this, so the velocity is perpendicular to the link like this. So if the link is rotating counterclockwise, so the link is rotating counterclockwise, so this velocity will be in the opposite direction, but perpendicular to the link. Okay, so that is the basis. So that means we know complete information about VA. Okay, then the directions of velocities you all know. Okay, so velocity B will be perpendicular to the link 4. So you know the direction of velocity B. Okay, so this is BA. So the velocity BA will be perpendicular to this. So we know the directions. It can be, so you can see the arrow up or down. So you can see up or down. So now you know completely velocity A. So you are plotting, so let us say velocity A. So now from the tip of velocity A, okay, so you plot the direction of velocity B to A. So velocity B to A should be always to the tip of velocity A. So because the equation is velocity A plus velocity B to A. So the arrows must be here. So you draw VBA. Okay. Now go back and you know the direction of velocity B. Okay. So just slide this here. Origin of from where you started velocity A. So now the velocity triangle or polygon is done. So now you can just measure the magnitude of this. That will be velocity VA. And also you know the orientation of velocity VA. Okay, so now you can fix the direction. Okay, so if you want to know the direction, you can use your geometric tools, or you can just draw a horizontal line and a vertical line. You can measure the angle. Okay, so the same thing. So now you started with here, right? So you know your global coordinate axis, your local coordinate axis. So then you can measure the angle of velocity. So whatever is, okay, always we connect, link 2 points. Okay, so now we know velocity b magnitude and direction. We also know velocity ba magnitude and direction. So once you know velocity ba magnitude, then you can find out the angular velocity of length. Okay, so once you know velocity b, then you can find the angular velocity of length 4. So you know the complete information. So if you want to extend this, so now you can link, say now you know complete information of B and A. So let us say there is another point C. So now you can link point A or point A to C or point B to C, and you can draw the same. So you can extend this analysis to 5-bar mechanism or 6-bar mechanism. Always in the exam there will be 6-bar linkage mechanism. Okay. So let us say you do this, okay, but your final velocities misses by 5%, let us say. You still get full marks. So it is not like 80%, you still get 100%. Okay, but you demonstrated some logical errors in drawing the polygons, and definitely your values will be very different from the original answers. So then if there is some logic, some understanding, then you may be given 50%. But if totally logically incorrect, then you will not get any marks. Okay, so velocity polygon this is the basis. Okay, then IC's method. So IC's method, you apply Candy's rule. We know that any 3 links in plane motion will have 3 ICs, and all these 3 ICs on a straight line. So for example, link 1, link 2, link 3 will have 3 ICs like this. Okay, so we know all pin joints on the mechanism will be ICs, right? So we know 1, 2 here, linking 1 and 2, 2, 3. So 1, 3 will be on this line. So similarly, next you take 2, 3, 4. Okay, so link 2, 3 and 4. So 2, 3 will be here, 3, 4 is here. So then 2, 4 will be on this line. So like this, you apply, then the intersecting points will give you the remaining ICs. So for 4-bar linkage mechanism, so you can easily find out. So only 6 ICs, right, for 4-bar linkage mechanism. So but this is just for understanding purpose. So in the exam, your question will be a bit more complex and a 6-bar linkage mechanism. So 6-bar linkage mechanism, you will have 15 ICs. Okay, so when you look at your question 6-bar linkage mechanisms, so first to draw ICs, to identify ICs, you need to plot the mechanism to scale. So when you plot the mechanism to scale, so sometimes if you have not practiced some problems, so you will go wrong with choosing the scale. Okay, so you may draw entire mechanism just very small, let us say. Then it is not possible to locate all the ICs clearly. So you make sure that when you draw, your figure should be able to, sufficiently large. Okay. So next, the accelerations. Okay. So acceleration, velocities and acceleration will be coupled. The first question. So velocity polygon and acceleration polygon. So the velocity analysis and acceleration analysis is very similar, polygon method or the relative velocity method. But here what happens, you have, because the mechanism is rotating angular velocity, so it is rotating along a circular path. So any point, okay, which is moving in a circular path, so it will have both normal and tangential components. Okay, so we don't use now x coordinate and y coordinate because now the path of the points are in a circular path. So therefore, circular path means the acceleration will have normal and tangential components, right? So we know about that. So let me just show you. So if let us say a point, so this is a circular path, right? So something is moving in a circular path, so the tangential acceleration will be like this, and the normal acceleration is directed towards the center. Okay, this is the center. So if the particle is here, then the tangential acceleration will be here and normal will be like this. Okay, so if the particle is here, the tangential acceleration will be like this, the normal acceleration. Okay, so here, because the reference frame is the normal and tangential components. So what is the formula for tangential acceleration? So tangential acceleration is simply r into angular acceleration. So normal acceleration, you can write either v square over r, or you can also use r omega square. Okay, so the normal component in a 4-bar linkage mechanism. So for example, let us say this is your link 2. Okay, so it has a normal component in the direction of the link. Okay, so then the tangential component, again it depends whether the link is moving counterclockwise or the link is moving clockwise. So if the link is moving counterclockwise as shown here, so the tangential acceleration is perpendicular to the link this side. So if the link is rotating the other side, so the normal acceleration, tangential component will change the direction. Okay, it will be in this direction. And normal will be still in the direction of the link. Okay, so you can identify, so once when you start the acceleration analysis, so you know the velocities, all the velocities. So that means you know the magnitude and direction of all the normal components. Okay, so magnitude and direction of the normal components. So that leaves you, again for point A, you know the tangential acceleration. So similarly now identify all the arrows. So for example, say point A, normal acceleration is shown, tangential acceleration. Now this is BA. So the normal is, so you can see that. So this is in the direction of the link. So now the tangential acceleration of BA will be perpendicular to BA. Okay, then you take B. Okay, so B, the normal acceleration of B will be in the direction, okay, of the link. So it is here. Then B tangent will be perpendicular to the link. So we know normal component, magnitude and accelerations. Okay, so now you can link 2 points. If you want to link point A and B, so just like velocity, so you can write acceleration equation. Okay, so you can write acceleration of B is acceleration of A plus acceleration of B to A. Then we have to include normal component and tangent component. So we just draw now all the directions are there. Now only thing is you need to combine these things as per the equation. Okay, so we know we start with A now, acceleration of A. So this is acceleration of A tangent and normal is just perpendicular. Okay, so that means what is the direction of acceleration of A? So acceleration of A is from here to here. So now what you are doing, you need to add acceleration of B to A. So you drawn tangent, you drawn normal. So now from the tip of this, so you are going to draw normal always because you know the magnitude of the normal and you know the direction of the normal. So therefore you are able to draw this BA normal. Now from the tip of this, draw tangent line. You don't know the magnitude of BA tangent. Okay, so now come to the origin. Okay, So now you know V normal, both magnitude and direction you know. Now perpendicular to that you draw the tangent. So you don't know the magnitude of this. So normally this line and this line will intersect. Okay, so that you can see in the next one. So once complete, so this is A tangent, A normal, BA normal, then this is the dashed line, BA tangent. So BA tangent, so this is the direction. So now here is B normal and B tangent you are drawing. So the B tangent and BA tangent intersect somewhere. So now the acceleration polygon is complete. So you know now you can measure the magnitude of B tangent and BA tangent. So once you know these values, then you can calculate the angular accelerations. Then you can also link now the point B to any other point. So you've done this for your assignment also. But for assignment, probably you have used the AutoCAD and it is rather probably mechanical for you to do. You can play with it and you can do with using software. But in the exam, you have to do on paper. Okay. And actually, some students they bring their own A3 papers. So you can bring your A3 papers, check with the examiner. You can also do on A3 papers and attach. No, otherwise you can simply do it on the given answer sheet also. So, but it requires some practice. Alright, so this is about acceleration method. So after this, then, yeah, so the next instantaneous centers. Okay, so this will be one big question for 30 marks, identifying the instantaneous center. Now, can you identify the instantaneous centers? So anyhow, I'll upload this file so you know. So, what is the instantaneous center is this?
1, 4.
So this is link 4, this is ground. This one?
1, 2, 3.
Where are the other instantaneous centers? So you can only see 3 instantaneous centers, right?
4.
So this is 1, 4, 1, 2. This is, so this is linking 2 and 3, and this is also 3 and 4. So there are 2 instantaneous centers. So you know 4, where are the remaining 2?
1, 3.
1, 3 is
Downwards.
downwards. Okay.
Then you have extended boundary, then the intersection point.
So you have 1, 4, 1, 2. So 2, 4 is on this line. Okay. So you know this is rather easy because you have 1, 4 here, 2, 3 here, and 2, 4 will be at infinity. So this is 1, 2. Okay. So this is 1, 4. Okay. So 1, 4, 1, 2. So 2, 4 will be on this line. So 2, 4 is on this line. Okay. So you have 2, 3. So 3, 4 will be at infinity. So 3, 4 is at infinity. So you are drawing a perpendicular to the slider. So slider is okay. So at infinity. So now you know 1, 2. This is 1, 4, 1, 2. So intersection point. This will be 2, 4. Okay. So then this is 2, 3. 1, 2. So on this line there will be 1, 3. And you have 1, 4 here, and you plot 3, 4 at infinity in the same direction. Just like this, 3, 4 at infinity. So you are plotting from here. Okay, so these two must be parallel. So infinity. So the intersection point will be 1, 3. So you can see this is a bit tricky IC's method. Okay, so now you may just draw basic, okay, hand drawn and try to identify the ICs. It will not take much time. So just try draw approximately. So try to identify. So it is a 6-bar linkage mechanic. So for that 30 marks question, each IC you will get 1 mark. So if you identify all the 15 ICs, so you will get 15 marks. So for example, you can easily identify all the pin joints, right? So you still get marks for those. So no need to draw to scale. So you can just approximately draw. So make sure the shape is maintained. So this will be 1, 2, right? This is 1, 2. So here this will be 5, 6. So then 1, 6 will be. So 1, 6 will be at infinity, perpendicular to the horizontal. So here one point to note is, all of you pay attention here. So this is a contact point, okay? And then this will be IC, instantaneous center also. So this instantaneous center is between 1 and 4. So here 1, 4 is not at infinity, but it is here. So what will be this instantaneous center? 3, 4. So you have 1, 4 here, you have 3, 4 here. Now, yeah, 1, 3 will be on the line. So this is one point you should note down here. This is an instantaneous center, the contact point. And another thing to note down is 1, 6 will be at infinity. So now I'll show you the ICs for this, so you can visualize yourself. Okay, so you can see this is 3, 4. So this is 1, 4. Okay, so you have 1, 2 here, So here you have three ICs. So this is the link between 2 and 3. So you have IC 2 and 3. And also this is 3 and 5. So this is 3 and 5. And also this is linked to 2 and 5 connect. So this pin joint indicates the three ICs. So 2, 3, 2, 5 and 3, 5. And of course this is where link 5 and link 6 is the slider. So this is the instantaneous center 5, 6. And 1, 6 is at infinity. So that means you can see 8 ICs right here, 1, 2, 3, 5, 6, 7 and 8. So the remaining 7 ICs you need to find out. Okay, so you can follow any method you want. You can identify, you can draw the circle, draw all the ICs which you have identified. So like this. Okay, so you know 1, 2, you have identified. So 2, 3 you have identified. So 1, 3 is common to 1, 2 and 2, 3. Okay, and this is also common to. So first you can 1, 2, 2, 3. So draw on the line. So you have 1, 4 also you're done. 1, 4 you're done. And 3, 4 you are done. So this 1, 3 is common to 1, 2, 2, 3 and 3, 4, 1, 4. So you can now connect 1, 2, 2, 3, draw a line. Okay, so draw a line. So between 1, 2, 2, 3, then 1, 4 is here. So 3, 4 is here. So 1, 4 is here, 3, 4 here. So draw a line, okay, joining 1, 4, 3, 4. So these two lines will intersect. Okay, so you can see 1, 3 is drawn between 1, 2, 2, 3, extending 1, 2 and 2, 3, extending. And 1, 4 and 3, 4. So 1, 4 is here, 3, 4 here. So draw a line. So the intersection point will give you 1, 3. Okay, so next we want to find out, let us say 2, 6. So 2, 6 is 2 and 6, this one. Okay, so 2, 6 is now common to 1, 2, 1, 6. Okay, then 2, 5, 5, 6. So this dash line is the triangle for this triangle and also this triangle. So it is, so now you have to link to find out 2, 6. So you need to connect 1, 2, 1, 6. So this is 1, 2. 1, 6 is at infinity. So draw 1, 6 at infinity from this point. So you need to imagine 1, 6 is at infinity. So draw a line from here, 1, 6 infinity. So you need to plot 1, 2, 1, 6. So you know 1, 6 and 1, 2. So on this line you will have 2, 6. Okay, so you have 1, 6 at infinity, 1, 2. So you are drawing the line. Okay, then you are going to draw the line between 2, 5 and 5, 6. So 2, 5 is here. So 5, 6 is here. Okay, so now you draw this line 2, 5, 5, 6, 1, 2, 1, 6. So the intersection point will give you 2, 6. Okay, so you can locate 2, 6 between 1, 2, 1, 6. Okay, then 2, 5 and 5, 6. So this is 2, 5 you have, 5, 6 you have. So on this line. Okay, 1, 2, 1, 6. So the intersection of these two lines will give you 2, 6. Okay, so then you can find out 4, 5. So the 4, 5 is between 1, 4, 1, 5. So you know, 1, 4, 1, 4 is here. So so this is 1, 5. So you know here 1, 6 is at infinity, 5, 6 is here. So 1, 5 will be on this line. Okay. So you can locate 1, 5, okay, which is common to 1, 6 and 5, 6, and it is common to 4, 6. So here 1, 2 and 2, 5. So this is 1, 2, 2, 5. So you join this line. So 1, 2, 2, 5. Draw this line. So this is 1, 6, 5, 6. Draw this line. So you can locate 1, 5. So first you need to locate 1, 5 before you go for 4, 5. So like this, so you have to find out the remaining instantaneous numbers. So you can see here some ICs, okay, a cluster of ICs you can see here. So this is 1, 4, 4, 6, and 3, 4 of course is visible. So 2, 4 is there, and 4, 5 is very close. So even on a CAD drawing, so there is a cluster of ICs here. So if you choose very small scale for your mechanism, let us say, then one point will show 2 or 3 ICs. So you need to draw sufficiently large. Only for ICs. Okay, for velocity polygon, the scale really doesn't matter. And sometimes, you know, when you draw the big diagram, the problem also, two lines may not meet in the given figure. So in such case, what you can do in the exam, you can just show, then draw a note. So the intersection point will give the IC number. So you will not be able to show in your drawing, but at least you can demonstrate that, you know, these 2 lines where they intersect, the intersection point will be, let us say, 2, 6 IC, something like that. If you are not able to show in the figure, so the 2 lines may not coincide. Right? So normally in exams you need to plot the mechanism to scale, then it takes some time to think. So it may take a long time. So 1 hour may not be sufficient sometimes. But if you practice, you understood your assignment well, then you've gone through the slides, you understood well, and you also practiced well, then you can do in 30-40 minutes. And you will be surprised in some of the previous exams, the students even scored 98 marks out of 100. So a number of students score above 90. So it all depends whether you understood. Yeah, it's a drawing, right? And the force analysis and the balancing is just calculations, very simple. So some effort is required, a bit challenging. Okay, so this is how you can find out the remaining ICs. So I just okay. So this one I just skip. So there could be anyhow. I'll be uploading this file. Therefore, you can go through all the questions. Okay. So in this case, again, finding the 15 ICs. Okay. So for this mechanism, these are the things you can identify by visual inspection. So for this mechanism, so even this is an IC, this is an IC. So all the pin joints, you can locate. So then again use the Kennedy's theorem. You can see how complex this looks. Okay. So during the pre-exam workshop, I think Professor Firoz will go through one such question. He will show in detail, okay, how you can locate all the 15 ICs. Okay, so this type of inline balancing, right? So we have done something very similar. So you can do sum of cosine phi. If you get inline engine balancing, it is mechanical. So you just do sum of cos phi, sin phi, sum of cos 2 phi, sum of sin 2 phi. Okay, then the next one, sum of a cos phi, sum of a sin phi, then sum of a cos 2 phi, sum of a sin 2 phi. So this is what we have done just now. So finally you get 6. Okay. So normally if you see, if you don't write and if you don't do yourself, everything appears to be simple. But normally in the exam you get confused. So shortage of time, and again too many things in your mind within the 3 hours. So that's one of the reasons why we strongly encourage you to write yourself. Okay, so this is a 4-bar linkage mechanism, like I said. So the dimensions will be there. So I'll just try to explain this. Okay, ground link O2, A, B, O4, B. So 4 links, right? So the global coordinate axis is shown, X, Y. The global coordinate axis is shown. Okay. So the length of the links are given. Okay. The angular velocity of the link is given. Link 2. Omega 2 is given. Okay. So what is that you can calculate here? You can calculate velocity of A, right? So velocity of A is this A to O2. So the length of the link multiplied by omega 2. Okay. So now the angular velocity is given. Yes, Michael. Anything?
Yeah, I just send you the email.
Done?
Yeah.
Okay. So because omega 2 is given counterclockwise, so you know the velocity of A. So now I will calculations you can see velocity of A O2. So you can just multiply the omega 2. So you can multiply the omega 2 with the length of the link. So you know the magnitude. And also you know the direction because it will be perpendicular to the point A here. Okay? So velocity A will be perpendicular like this. So this is already given 120. So what will be this angle?
60. 60.
No. So this angle means you need to get a local coordinate axis, okay, then measure this. So that will be 120 plus 90, 210. So the direction of velocity A will be 210. So now you choose a local coordinate axis like this, okay, for drawing the velocity coordinate. So you are drawing now the velocity A is this vector. So you are drawing at 210 degrees. So the magnitude is, let us say, 4,500. Now from the tip of this, we know the direction of velocity B to A. So velocity B to A will be perpendicular to this link. So perpendicular to the link BA. Okay. So if you are not sure, you can choose a local coordinate axis, so you can measure what will be the angle. Okay. Otherwise, using your set squares, you can just slide and show that this is the line velocity B to A when connected to the tip of A. So this is your velocity B to A. So now we have drawn velocity A and velocity B to A. So that should equal to velocity B. So now go back here and you know the direction of velocity B. So you can check velocity B, the direction will be perpendicular to this link. So it will be like this. So now the same orientation you draw from here, velocity B. So it is a line. So now these two lines will intersect. So now this is velocity A, this is velocity B to A, and this will be velocity B. So you can get all these things. So velocity BA is measured, okay, and once you know velocity BA, you can calculate angular velocity of link 3. Okay, then you know velocity B, then you know the length, so you can calculate angular velocity of link 4. So that means you can calculate angular velocity of link 3, link 4. You can also calculate velocity of point B. Alright, so this slide, there is a 6-bar linkage mechanism, so there is an example. So there's not enough time for me to go through this, so there are some more examples here. So these are about velocity imaging. So we touched upon velocity image in the previous class. So how to use velocity images are explained here. Okay, it's basically an example of velocity imaging. Then you have an example about the dynamic balancing. Okay, so you can go through. So this is again a 4-bar linkage mechanism. So this is a 4-bar linkage mechanism. So these things comes with a bit of explanation, and this is basically an example of Coriolis acceleration. So you can just go through this. Okay, then this is about your assignment. Okay. So anyhow, I have gone through this. So the last portion you can complete everything based on what you have done for force analysis. Okay, and you need to write one thing with the question you see. Okay, I have not copied the question. So if you want to reduce the shaking force, what are the suggestions you need to make? So we need to write just a few comments on the balancing of the mechanism given to you. Now to do that, you can just Google online and whatever you get, you can just reproduce. But you need to touch upon what type of balancing mechanism you will be applying or you will suggest to use. So that is half a page you can write. Alright, so I stop here. So I wish you all the best.